We've seen that the resistance of a thermistor decreases with temperature in a smooth curve. So, does the resistance of a light-dependent resistor change with the brightness of the light falling on it in the same way? Let's do an investigation to find out using an LDR and a digital light meter. We'll change the brightness of the light falling on the LDR and find out what happens to its resistance, while keeping everything else constant. It's a very similar setup to our thermistor investigation. We use the light meter to measure the brightness and a multimeter set up to measure resistance directly. The brightness of light falling on a surface is measured in a unit called lux, but we don't need to worry about the exact unit. For us, it's just a way of putting a number on the brightness. As we increase the brightness of the light falling on the LDR, we can see that its resistance decreases. And if we plot this on a graph, we can see that the resistance drops off in a smooth curve. The resistance drops sharply to begin with, and then once the light is bright enough, the resistance stays fairly constant. You can see that the resistances of a thermistor and an LDR change in a similar way, and this is because the mechanism is similar for both. Both the thermistor and LDR are made of a material called a semiconductor. We can imagine the semiconductor has both positive and negative charges that can make up a current. At a very simple level, as temperature or light intensity increases, more and more neutral particles are split into positively and negatively charged ones. These extra positive and negative charges are free to make up an electric current, and this makes the thermistor or LDR better at conducting. Better conductors have a lower resistance.